And welcome everyone. Eh, So yeah, as Ryan said, today we're covering understanding your choices in reality capture, where we're going to go through a little bit of basics and then on to other more specific hardware related things. This is one of several classes that we're offering. There's actually one on here that's not on the list yet, which is pedestrian simulation that we'll be offering soon as well. Eh, So, real quick, before we get going, just to give some background on who PMC is, just so you have a general idea. Um, we've been around a long time, a lot of clients, lots of projects, lots of people. Um, but it's specifically, for today's discussion, we're one of the largest scanning companies on Earth, and we've done projects of every size imaginable, ranging from stuff that was a single scan up to the largest, being over 20,000. It, we have offices scattered around the world. PMC started with in the automotive industry, so we have offices strategically located to support some of our manufacturing clients. Then we do a bunch of other stuff too, if you're interested. But that's it for today. So a little bit about me. Again, just to give some background. I've personally scanned over 100 million square feet. As a company, we're getting close to 1 billion square feet, and been scanning over 20 years at this point, between actively being out in the field and scanning to managing, a team of people that are scanning. Yeah. So, real quick, why are we talking today? So, back when we first started scanning, right around the year 2000, 2001, that time frame, there were two types of scanners, two manufacturers, and two units available, and that was it. Both were laser based, both were really slow, and both were incredibly expensive. We're talking the $500,000 range. Here we are, almost 25 years later, and there's just been an explosion of different types of equipment from not just, the same equipment from different manufacturers, but the underlying technology behind the equipment is very different. And the results you can expect to get from that piece of equipment are different. Hey, so here's going to be sort of the order for today's seminar here. We're going to start with, a little bit about scanning and reality capture, just to kind of set a baseline of what this stuff is, how it works, how it's measured, that kind of thing. And then we'll jump into some specifics about the different types of equipment that are out there. And then finally, we'll move into live data, looking at data from different types of units. Um, and so you can visually see what you can expect. This isn't, a super deep dive into these. That would take a long time. But it's to give you a general high level overview of what the different data sets look like, including their online virtual tour viewers, plus what the data will look like within a CAD application. And that we'll jump into a little bit about reality capture. Um, so what is this? What are we talking about? So it's the process of digitizing the real world. So we're taking some kind of device out into the real world and we're capturing what's there in some dimensional way. Um, Today, the two primary ways that we're going to do that are either with a laser, some device that has a laser that shoots out, measures the distance, and records that information, or we're going to do photogrammetry, which is we're going to take a ton of normal 2D photographs and have them stitched together and let software figure out a 3D point cloud from those 2D photographs. And then there are devices, Matterport's being one of them, and a few others that are somewhere in between those two things, kind of laser supplemented photogrammetry. Eh, on a conceptual level, important to understand here is when you're talking about the laser devices, which is the majority of what's out there, not this doesn't apply to photogrammetry. But the majority of laser-based devices, those lasers are either going to record data in black and white, meaning every measured point is going to be white in the scan, or they're going to do grayscale, which is how much of the light energy was lost when it or was absorbed by the thing it hit, and it returns a grayscale image of it. Um, Anything that has color capture is being done with a secondary camera. So the data might be color, and the point cloud you pull into Revit or AutoCAD or whatever will look colored, but that's because of a secondary camera was used to capture that color information. That's not actually the laser capturing the color. And why this can be important to understand is two things. One, especially when you get to the mobile units that are almost always going to be black and white lasers, they're not going to do intensity. Um, if the lighting is not good enough for their camera to work, you're going to have a lot of problems with the data. It's going to be very hard to see because they don't have the option to switch over to grayscale. So in this image that's in the bottom here on the slide, that was almost completely dark when that image was taken. And yet we can switch it over to grayscale and see it. If we were looking at it in its color view, it would be almost black. You wouldn't be able to see anything. The other reason that this matters nowadays is that a lot of the ultra fast laser scanners that are on the market, including units from Faro and Leica, they're using some interesting trickery with cameras to increase the capture time. And the end effect is that the photos they're taking don't perfectly match up with the laser scan data. And so you can end up with some sort of strange artifacts in the data from that. So, high level here, how do we do this? We're going to plan the project. Someone's going to show up on site to capture the data. Then something has to be done. Traditionally, this would be the registration process of combining multiple scans together into a final point cloud. With the mobile units, there's still a process here, but it's a little different. It tends to be faster. With photogrammetry, this is a lot of alignment of photographs that goes on. But basically, there is a process between the time on site and the time we're generating, maybe an RCS file for use in CAD. And depending on the technology used, that registration process can take more time than the on-site scanning did. Um, Whereas in other things like, let's say Matterport, the registration is typically done before the operator ever leaves the site. Okay. And then from that point, you're going to generate different outputs. This is traditionally going to be the web viewer, a virtual tour type viewer, and the RCS files to go into some kind of CAD application. However, there are a lot of other outputs available as well. So when we're talking about fixed scanning, this is the traditional scanning that's out there. This stuff has been around, like I say, since about 2000. Um, Works extremely well, very well tested. This is the tool that just is going to get the job done. There's never going to be a question. There's no sites that are too big or too strange for this technology to work. Um, like any kind of capture, it's best to do when the site's inactive, meaning there's not a lot of people or vehicles moving around on the site because it will scan and capture those things. This even applies to outdoor work. It will actually scan snow and it will make a huge mess of the point cloud. So you need to put a little bit of thought into that. Um, Depending on the size of the project, you might need secondary targets. We'll talk a little more about that. Um, and then if you want to do repeated scanning with this device, you can install permanent benchmarking on the site to let you go back out and scan the same thing over and over. This would be maybe for construction site monitoring, or we do this a lot in factory work to track changes over time. A little different than targets, right? These are things that get left behind and permanently added to the structure. So I think it's important to talk about because we're going to talk about the accuracy of these units in a second. Where do the different types of capture devices get air from? Um, in fixed scanning, air comes because each individual scan has a certain amount of error. So modern scanners have a published error rate per scan of plus minus a millimeter. These are the terrestrial units used for scanning buildings. They're all about 1 millimeter nowadays. Um, that 1 millimeter seems great, but then if you do two scans and you stitch them together, well, now all of a sudden you can have 2 millimeter error. Extrapolate that out to a very large site with hundreds or even thousands of scans, and you can see that the error stack up becomes a serious problem, right? We could all of a sudden be talking about errors in the neighborhood of a meter, or several feet. Um, so to counter that, what you do is you use targets, and that will help lock things down at first because targets let you match up two scans together tighter, much tighter than that 1 millimeter even. Um, and these are spheres, checkerboards, there's a bunch of different types out there. And these get set up throughout the space and taken down as the operator moves through the space. As the project gets even larger in size, even these targets are not alone sufficient. And so then we come back in with traditional survey equipment. And where a scanner, has ranges that are, maybe 50 to 100 feet of usable data, the survey equipment can shoot 1,000 feet or more and get you much, much more accurate information on these exact same targets. And that helps remove even more error from the registration, allowing you to get some really, really tight data, um, at scale. So, like I mentioned earlier, registration is this process where we take these individual scans and we stitch them together into a point cloud. Right, each individual scan is going to be line of sight, and we're going to do several scans per 1,000 square feet, depending on the density of the location we're working. And these all have to get stitched together into something. This process is registration. This is also where the error can get introduced if you're not careful in what you're doing. Also, as mentioned in terrestrial scanning, this process, although there are solutions now that let you register as you scan, none of those work good at very large scale work. They all start to have problems as buildings get, maybe above 20, maybe 50,000 square foot at the high end. So if you have sites bigger than that, those on-site registration tools tend not to work, and you're going to have a pretty sizable amount of office work to do after the scanning is done. Um, Mobile scanning and SLAM type scanning. This is the most actively developing world out there in the scanning business. Um, and it's really sort of split into two factions right now. One is what's up here on the screen, the units from NavIs. These are sort of the high-end mobile scanning units that, when done correctly, are extremely comparable to terrestrial data in the quality of data you get at the end. The other half are these newer generation handheld mobile units. They're going to have much lower levels of accuracy, and there's so many of these units that have hit the market in the last even the last year, that it's hard to even keep track of exactly what they all can do and not do. Some support survey points, some don't. Some can only capture black and white data, some can capture color. Um, Again, these are the handheld units. There's dozens on the market now. Um, and we're not going to talk a lot about those today just because it's such a new market, and they're sort of all over the map right now. Um, but the key here is these units, when done correctly, are going to be much faster, right? So whereas let's say scanning 10,000 square feet with terrestrial scanning in a relatively densely packed environment, That's maybe going to take you half a day or even a day in some cases if it's got enough stuff. You're going to cover that in an hour with these mobile units. It's basically going to scan as fast as you can walk, not run, but at a brisk walk, it will capture data. Um, and at least say with the NavIs units, it's going to be pretty good. With the handheld units, it's going to be much looser, and it's a little hard to pin down yet on exactly what that accuracy is going to be. Hey, so it's like we talked about with the terrestrial units, we're going to talk about air in SLAM units. So whereas a terrestrial unit has a single scan, a single setup that might capture 1 million, 2 million points, and all of those will be about millimeter accuracy. SLAM is capturing data constantly in real time as you move. Um, that data it's capturing is technically still, usually within a couple millimeters. Um, but the bigger issue with SLAM is something called drift. And SLAM is just an acronym for the algorithm that powers all of these mobile units. So as you move through the space, where you actually are versus where the unit thinks you are will start to drift apart. The longer the walk, the worse that drift can get. And it can relatively quickly get so far out of alignment that the data is unusable. Um, and so there's techniques to get that data to connect back up. One of those being you always will do this work in loops. So you'll start at a location, you'll walk a big loop around a building, and you'll end back in that same location. That will help, but it won't completely eliminate drift. The next step up is to put in what are known as targets or anchor points. And so similar to the other type of scanning, right? These are fixed points in the space, and they're going to be picked up by a traditional survey team with a total station that's going to get all these points to a much higher level of accuracy. But there's going to be very few, right? On a 20,000 square foot building, there can maybe be 10 of these points total. On 100,000 square foot, maybe it's still only 20 of these points that need to be put in. So the survey will go quick, they'll get hit, and then you just walk the space with the scanner. Um, again, on the NavIs unit, you're just going to actually walk up and touch a point on a wall that has one of these anchors, hit a button, and you've locked in. With the other handheld units, some don't support this at all, which means they suffer from horrendous drift. Others do support this workflow, but they can be a little different in how they pick up these anchor points. Um, so there's not necessarily traditional registration with these units. This is more a data processing thing. All of these units, for the most part, there's only one exception I know of right now in one of the handhelds, but all the rest will require you to upload the data to their cloud service, and that service will take care of the registration work, which is really more correcting that drift we just talked about. So within the software on their cloud services, they will attempt to correct that drift. They'll do things like apply that survey data that we talked about with the anchors that you put in, anchors or targets you put in. Um, but this is a process, but in general, this process is very quick. We're talking, even if you scanned for 10 days and picked up, 1 million, 2 million square feet, this process is only going to take, um, as a person activating it, a couple hours. It might take overnight for the cloud service to process it, but no one has to be there while that happens. Right. So a key part to talk about in all of this, whenever you're getting into it, is understanding that um, point clouds are not aligned to anything in the real world. They're going to come in some arbitrary location, typically based around where the scan the first scan, or in the case of mobile, where your walk path started, and that just becomes 0, 0, and whatever direction you happen to be pointing will establish the rotation. Um, if you're doing survey control, that typically will get the data to align. If you're not doing survey control, then you have to manually align the point cloud to something. At a minimum, you're going to want to square it up, right? Get north pointing in the right direction, get it rotated correct. And this happens in that registration step or point cloud processing step. You should never be moving a point cloud in a CAD environment. That's going to end bad for you. It should happen in the registration or processing step. And typically, if a CAD file of some kind or a BIM exists, we're going to align to that by picking some known points. Um, in the case of survey, you have a lot of options, right? You can get it onto state plane coordinates. You can tie it into various benchmarks in the building, building corners, whatever you're doing. If you don't have that survey, it's going to be more of a manual best fit kind of endeavor to do that. And this is going to include getting the origin point right, the elevation correct, and the rotation correct. In general, the roll and pitch or levelness of the scan, that should all be handled by the scanner and the registration software. It's not something you should get necessarily involved in, but you will need to establish the origin point, um, the elevation, right? So on a lot of architecture work, that's going to be positive 100 to the main the floor you walk in onto. And then the rotation, right? Which way is going to be north? Yeah. Um, output. So a lot of different outputs out there in the world. We talked about the main ones, right? The main ones are going to be the virtual tour and the RCS nowadays, the Autodesk format for bringing into Revit or AutoCAD. Those are going to be the two primary outputs. There's then a whole slew of different analytical outputs. Um, Automated tools that will do construction completeness or construction accuracy reports, floor flatness reports, um, subsidence reports of a building sinking. There's all these other outputs that can be done. But the two big ones are going to be the virtual tour and the RCS that you're going to bring into CAD and work from there. One thing to talk about, because some people are still a little confused on this, the output from any of these devices we're talking about today is a point cloud. And this is what we're looking at here on the screen with you can see the occlusions. Right now it's switched over to the Revit model, right? So there's a big difference between a point cloud and a model. In the simplest of terms, in a point cloud, um, you're probably not going to do design work in a point cloud, right? You're going to need some kind of Revit model to do the design work. There's, of course, going to be exceptions. You can integrate point cloud in some interesting ways, but typically, like if you're coming into this hotel and your work is to retrofit this hotel, you're going to need to convert that point cloud to a model. And while that's not a topic of today's conversation, just understand that that's a process to go through, that there are not automated tools that work very well. And it can take a very long time to do that over modeling that essentially today is really tracing. They say there are some automated tools, they work to varying levels of success. At the end of the day, if you want to model something like this hotel we're looking at, this is a very manual process that takes a fair amount of time. Hey, with that, we've covered kind of the background. So let's jump into the equipment choices, and then what's out there on the market and the pros and cons. Hey, um, the biggest thing when we talk to people, because we use most of this technology, we own most of these different devices at this point. Um, this is the main question, right? Does it capture the data that will let me solve the problem or answer the questions I have about the space? Um, there are jobs where something like a Matterport that is not very accurate but is fast is perfectly adequate to do. We're doing a lot of this work nowadays. There are other times where it is not appropriate at all, right? If you're gonna try to do complex construction coordination, a Matterport is not appropriate. It's not accurate enough. It's going to have huge problems. Um, so the but you also don't want to take a unit that's overpowered into a space either that's not necessary. So picking the right solution for the problem or questions you have is an important one because it affects ultimately the time it can take and then the money it can take to do the work. It- so when we look at accuracy, we try to refer to the USIBD, the U.S. Institute of Building Documentation. They've kind of defined these 5 levels of accuracy. For the discussion today, 10 and 50 are really not topics. 10 is going to be like your mobile mapping data, where you're picking up, huge volumes, maybe from an airplane. Um, and accuracy is obviously here pretty loose. Um, then at the very low end, the LOA 50, this is going to be a reverse engineering stuff. There's a whole fleet of other devices that do this work. Know that, just because a Faro unit says it can hit 1 millimeter plus or minus, you are not getting that level of data out of it, right? It's don't necessarily believe the spec sheets that come with this equipment. So if we look at the other ones, right, that are in there, LOA 40 is going to be the land of those traditional fixed laser scanners. They're really the only thing out there today that's going to deliver that accuracy of data, and that's only when they're used correctly, and the registration is done correctly. As we move up kind of the scale, I would say right between 30 and 40, somewhere in that, little space in there. I guess it's really in 30 because 5 millimeters is about as accurate as you're going to get, is things like the NavIs unit, the mobile unit. Again, these only apply if it's done correctly, right? With any of these, you can have bad technique and you can get bad data. Um, as we then move up again, photogrammetry is going to fall in the high end of the LOA 30. You're not going to get 5 millimeter out of photogrammetry, but you are going to get 15 and below, maybe to 10 out of photogrammetry. This is what we use today for any kind of site work, roofs. We do all photogrammetry now. Um, and as we move up again, like I was saying with these handheld mobile devices, it's not really clear to us exactly what the data quality is that's coming out of them, but I am confident it is definitely somewhere in the LOA 20 range. But obviously that's a huge range, right? A lot of projects, 15 millimeter is probably okay. 50 is definitely not okay. Um, exactly where these units fall is still up in the air. We need to do some more testing and get a hold of these units and compare them back to known survey data. Eh, Other thing to consider, right, is accuracy is one thing. That's, the accuracy of a measured point, or ultimately the registration work. Resolution is another thing to consider. Um, you can, depending on just how far away. So modern terrestrial units, some of them can go over 300 meters in range, but at 300 meters your resolution of the measured points is going to be, you know 20-30 centimeter between points. That's probably not very useful when we're looking at like a building facade or something like that. um so you can lose detail between the resolution. Interior space where this can come into play is with some of the solutions like Matterport tends to have a much lower resolution. There's a new technologies from Faro and Leica, those ultra fast ones we talked about. They are doing some interesting photogrammetry and laser fusion, let's call it. They can also suffer from this resolution problem. So it's just something to keep in mind when you're scanning and the level of detail you need. So let's say, for example, you are very concerned about historic stonework on a structure, and you want to make sure you're getting the grout lines between, big limestone panels. This can be a problem, right? You can actually lose those grout lines because the distance between dots becomes bigger than the grout line. Um, a little more about these units now. So the traditional terrestrial scanners, these come from a ton of different manufacturers. The biggest ones being Faro, Leica, Trimble has some new stuff, and there's a few others out there. Um, and in addition, there's a lot of manufacturers that deal in specialty equipment. So if you're doing oil and gas work, you might need explosion proof scanners, those types of things. Um, I said before, these are the units that have been around a very long time. They're very accurate, very stable technology, very flexible. If you want to do, let's say, above drop ceiling, if you want to get that interstitial space, these are today really your only good solution for that. Some of these mobile ones might get there pretty soon, but they're not there yet. Um, these are the ones you can stick out of windows on huge booms. We do elevator scanning where we flip the unit upside down and boom it inside of an elevator shaft. Um, all this work can be done with these. They say very flexible, very stable. They just work very well. They're a proven technology. Uh, As we then get into, the mobiles, honestly, today, like I said, there's other units out there, but basically Naviz is the only, in my mind, the only kind of legitimate player in this space of the high accuracy mobile units. There's drawbacks to these units too, but they're really the only one out there. And these units are going to capture, huge volumes of space in a day. The data quality is going to be, for most projects, very acceptable. Um, Most projects that we would do with a traditional fixed unit can be done with a Naviz nowadays when it's done correct, right? And what I mean by correct is that you don't try to push the the matching, the SLAM algorithm too far. You run secondary survey control when appropriate. If you do those things correctly, you'll be fine and you'll get data that's very usable out of these units. One of the things I suppose I should talk about, well, actually, I'll talk about in a minute, is the cost of these units. Um, Again, it's a fast developing technology here. Expect to see more people competing in this space soon, with units that are very similar. Uh, these algorithms we're using are for the most part public, although each company has their own spin on it. The laser units can be purchased by anyone. You can see them here on the unit, these pucks. These are Velodyne laser scanners, same thing you see on self-driving cars. Um, Easily purchasable by anyone. So I expect to see more innovation in this space. Handheld mobile units we'll move into now. Like I said, these are the a bit of the Wild West of um, units on the market today. At a conference I just went to, I bet you there were a dozen new companies that I had not even heard of that had units that looked almost identical to the Faro Orbis. How they implement color capture is a little different from unit to unit. Some just don't even have it. Down here, you can see this little marker down here. This is for picking up those anchors we talked about to tighten up the data. How different companies implement that or don't implement that is varies. Um, right now, like I say, these units are brand new and expanding. Even though some of them, the company that Faro bought that may predated the Orbis called GeoSlam has been around for a very long time. Um, there's been an explosion in the number of these units recently. Right. Photogrammetry. This is a space that keeps improving and getting better. Um, very interesting space, and really, I mentioned before, we're seeing this even percolate into some of the laser units that are doing hybrid. Any of you that have the newest iPhones that are out there, that's what that is, right? They claim to have a LiDAR unit. They're not laser scanners. They're LiDAR assisted photogrammetry, meaning that if you take a photo and then you project a little LiDAR on top of that, you can scale that photograph. Um, but you also don't have to do that. You can just take a ton of photos and turn that into a point cloud as well. Um, and this works really well. The more photos you have, the better it gets. Um, the more CPU and processing resources you have, the better it gets. And I think in some point in the future, this replaces most of the lasers on the market as this technology will continue to improve and get better. Today, there's no question for site capture and roof capture. Photogrammetry is the way to go. It takes a fraction of the time. You can do it with very inexpensive consumer level drones now, that have cameras on them that are plenty good enough. You can also do some more advanced stuff with some of the more powerful drones. You can do heat measurement infrared stuff, which can be great for figuring out where leaks are happening on roofs and things like that, condition assessments. Um, yeah, so neat technology that continues to evolve. It, Last thing I want to touch on, because it's sort of this thing to itself. Actually, I should update this slide. I really shouldn't say photogrammetry anymore. This is Matterport. Uh, the Matterport 2, which is there on the left, was an interesting device, and it took over clearly like the home real estate market. Right? Anyone who shopped for a home in the last, 4 years or so, you probably saw these virtual tours powered by Matterport. Um, and it was great for that, but it was not good for a lot of other larger work. Um, they've since, in the last few months, come out with the Matterport 3. It's a substantial improvement to both the capture speed, and very importantly, the quality of the capture is dramatically improved. And we're still testing this at PMC and doing some actual number checking on it, because confusingly they claim it has the same accuracy as the Matterport 2, yet it seems to be delivering much, much better data. So we're going to do some tests on this and see exactly what's going on. I actually have some data we'll look at in just a minute that just came from the 3 yesterday, I believe. Yeah. So let's do some comparisons on the different units, right? Um, as we go through them, the practical range on these, we'll start with the fixed terrestrial units or the accuracy. I would say, plus minus zero point 0.2 inches, quarter inch is realistic of what you're going to get. You can get tighter, you can do some things to get better data, but if you're doing a building that's of decent size, if you do it correctly, you can consistently get about a quarter inch of accuracy on that building. Um, the capture speed, medium, I'd put it. It's sort of all over the map, but at the bottom line is, right, you're not moving in real time. It's going to be slower, and it's not as fast as Matterport's. It just takes a little longer to capture. Plus, as we talked, you have that office work after the fact on bigger jobs to run. And then range, 50 feet, give or take. Obviously, these units proclaim to have much longer ranges, and that's great if you're in civil engineering and you need to capture huge sites at low resolution. I assume most people on the call are going to be in the building world. In there, I'd say, the practical range is about 50 feet you're getting out of these. Um, that said, there are some higher end Leica units that can get some incredible accuracy and resolution at incredible ranges. Um, but those are, again, we're getting to those specialized units that do different things. Um, as we move down into those Naviz mobile units, similar specs, right? But it's going to be a much faster capture speed, uh, about twice as fast, maybe more than the fixed units. And you're going to have an accuracy that's about twice that of the terrestrial. Again, when you're talking these accuracies, it's hard to lock down. There's a lot to unpack there as far as what does accuracy really mean. Are we talking accuracy about a single object in a space? Or are we talking about the overall accuracy of the entire building, right? If we measured building corners, how accurate are we? But roughly it's going to be half that of a fixed unit. Moving on to these handheld units. Again, these are kind of all over the map. I say 2 inches. I think that's pretty safe to say. They're going to be fast, and the range is going to be short. Like I said, a lot to consider here on these as far as how they actually work and what functionality they have. Any step up into the drones, right? I would say 1 to 2 inch is what you're going to get. You can actually get a little tighter. You can get down into like the half-inch range with some really good sight control and a lot of photographs. But the range is, enormous, right? We're flying these drones a few 100 feet in the air and taking massive photos that then get stitched into a point cloud that has, resolution where you have a dot every couple millimeters. So incredibly long range. Then lastly, we're going to move into the Matterport. Again, like I said, the Matterport 2 was not very accurate. It had some issues. It had a lot of junk in the data that would show up. The 3 is a massive improvement. We're still sort of testing our way through it. These are going to be 30-second scans, very lightweight. You just pick it up and move it. You're going to have a tablet that registers on site. If it has cell connections, it's going to upload that data to the cloud. And by the time you're done, your project's done and you can work with it. Oh, this has a couple mistakes on it, but I'll talk through it. So processing, for some people, right, this is important. Where can you process the data? So with the terrestrial units, this used to be local only, meaning you needed a high-end machine to process the data once you got back to the office. Now, most manufacturers, not all, offer some kind of cloud solution for processing, so you don't need that processing power on site. But all of them, to the best of my knowledge, if you have security requirements, they do offer, local solutions that are not cloud-based. And we move into I apologize for the typos here, as we move into the mobile units from NavIS, processing is 100% cloud-based, and so is hosting. These are our mistakes now. It's actually just, well, one's a mistake, one is old data. They removed the local solution. However, if you are like a government entity or something like that, they might give you the ability to process and host locally. But for the general public, that is not an option. 100% cloud-based for processing and hosting. And then any of these cloud solutions are going to come with a price tag to match, right? You're getting a huge amount of processing power being given to you by them, and it's going to cost money to get access to that. The other units, the handheld and walking units, as far as I know, there's only a single unit that allows for self-hosted processing, local processing. All the rest require cloud processing to work. The hosting is not necessarily relevant in a lot of these, but it is in some, mainly because these don't usually support virtual tour type workflows. Say some do, some don't, but a lot do not. The hosting is going to cost less money than the nav is because there's less processing going on with those. Photogrammetry is cloud or local. Same with the hosting of that data, cloud or local. And it's cheap because there's a ton of competition in this market. So the prices for processing the data are amazingly inexpensive. It can get very expensive. Some of the really high-end Um, Local processing solutions are costly, but in general, it's going to be pretty cheap. Um, and lastly, Matterport, uh, cloud only on both. There is no local option for processing or hosting. Um, and this is getting more expensive. They're starting to increase the cost. So it used to be to get exported point cloud data, which is what you need if you want to work on it in CAD. They were charging, I think, $87 a project. That jumped to 103. Um, and that might not seem like much, right? Whatever, it's $100. But Matterport tends to operate best in high volume, small spaces. So convenience stores, fast food restaurants, strip mall type locations where you're maybe exporting 100 or 200 locations. Suddenly $100 a piece gets a little pricey. Um, and that's outside of the hosting costs. That's just what you're paying after the fact. The one thing I didn't cover in here that I'll cover really quickly is the hardware cost. Um, and that is going to start at the terrestrial units have a pretty broad spectrum of cost, starting at maybe upper $20,000 per unit to some of the highest end units can still come in at 100,000 and up, depending on what you're doing with them and how specialized they are. Uh, the Naviz mobile units, you're going to be looking at right around, 80 to $100,000 to get started. Um, the handheld units, and this is actually one of their major problems, is that they seem to be priced right around the mid 20s right now. And when you're charging 25,000 for that unit and you can buy a terrestrial unit for the same price, that's a problem in my mind. Um, the drone's going to be super cheap. $500 commercial consumer level drone, you're into photogrammetry and it's going to work well. Um, Matterport's cheap. I think we paid less than 7,000 for our Matterport 3 that we bought just a couple weeks back. Um, and the combine that with the hosting stuff, it's definitely an inexpensive solution. Well, I think, modern stuff, the virtual tour part of the software has become almost as important as getting into a cloud environment. On most projects, you're going to actually have far more people accessing and using the virtual tour than you're going to have people working in CAD with the data. So this is actually a pretty important part of this capture stuff. So if we look at, like I said, it's a mess in the handheld mobile units, so we're going to skip those. And then the drone photogrammetry stuff really isn't the same virtual tour. So for now, we're talking about the fixed, the mobile, and the Matterport. Um, visual can matter, right? If you're in the business of high-end architecture kind of stuff, right? Visuals are important. Um, the Faro stuff that's out there, the Leica stuff, it's okay. It looks okay. We're gonna look at some of it in a minute. It's just not as visually nice as the other two. Naviz is better. Matterport is clearly the best, in my opinion, for the virtual tours. Okay. Accuracy of measurements in the virtual tour. Okay. Again, the terrestrial, the traditional stuff is going to be the best for that. I tell you, Naviz has improved some of it and it's getting better, but you're still going to have some issues. Matterport's a little questionable for taking accurate measurements out of the virtual tour. Right? We're not talking about in CAD, we're just talking about that. Um, for some people, VR support has become a big requirement. Uh, Pretty much as far as I know, all of the terrestrial stuff does support VR. Some is extremely easy, like WebShare. You plug goggles into a computer, it knows they're there, hit a button, you're in VR. Same with Matterport. Um, the Naviz right now does not support VR. And then, do you have security problems or challenges that maybe make cloud hosting an issue? Uh, again, we talked on this a little bit, but terrestrial, they have options. even though they're dwindling and they're taking some away. Um, Nav is maybe, right? From what I've been told from some people, Nav is depending on who you are, and if you're a large enough customer, perhaps you can make that happen. Um, and then Matterport, just no option at all from discussions we've had with them over this. Right, these can be issues if you're, a government entity or working with a government entity. And with that, we're going to jump into some live data reviews. Today, we're going to cover most of them. Well, I tell you what, we'll start with the virtual tours and we'll go through those real quick. And then we'll jump over to Navisworks to actually look at some of the data. Navisworks give you a good idea of what it will look like in CAD. It's not exactly, what it will be, but it will give you a pretty good idea and better than watching me load point clouds for an hour in different CAD applications. Hey, so with that, we'll jump in. So this is a virtual tour, right? Notice I'm in a web browser. I say these are a really important part of the deliverables we do today. Right? These spheres are going to indicate where individual scans were taken, right? So we can jump around to different locations. Right. Remember I was talking about with the quality of the lighting with some of these solutions can be a big problem. Um, and here we could always switch to this should have intensity based, data, which will help us see things better. It's going to be especially important if I were to jump up here into some of the above ceiling capture that's been done. Right, so if you look, right, this is the above ceiling line. Remember I said that we could use the terrestrial units to get up into this space and capture the interstitial between the drop ceiling and the roof deck. And this gives you an idea what that looks like, particularly for MEP work, right? This can be very important to understand what's up there. And all these, are going to have an overview map where we can check out different, views. Um, and you can measure things, right? And all these you're going to be able to measure, annotate. Some have some different options, right? So this particular viewer from Faro for terrestrial stuff, we can take a very high-res orthographic photo that's constructed out of point cloud data. So it can be an interesting way if you have maybe a really long building and you want a consistent ortho photo of the whole building. This can be a neat way to get that information. Jump over into Ivion really quick. Um, right, again, we have the map where we can move between things. Right, and the different, in this case, these circles don't represent scan locations. What they're representing, because a scan is happening all the time in real time. Um, these are representing locations where the operator pushed a button to capture a panoramic image. Mm, and again, we can come in, we can take some measurements here. So I was saying they've actually gotten better with their the quality of this measurement tool, in that we can actually sort of see what we're about to measure. Right? Am I actually on the edge of this thing, or am I? It's not wanting to let me actually take a measurement. Right, but this is the problem when you try to take measurements in a virtual tour, is that you don't usually know exactly what you're clicking on. And I could click down here and actually mistakenly grab a point that's on even a different floor in some of these. Right, but here they've done a much better job at implementing this. All right, and so we can take some baseline dimensions. Wouldn't always trust these. If it's a critical dimension, you really need to be in CAD to make sure that you're getting the accurate dimension. Eh, Then lastly, we're going to jump over into Matterport. And here, just to mention, right, VR ready. If I had VR goggles plugged in, I could just jump right into VR. Um, does a nice little, dollhouse view. This is something new that's just been added, which is they auto-calculated spaces in here, which is interesting. Um, all right. I don't know how much I trust this, being that it was generated by a computer and we already found a bunch of problems with it. So, but not bad. And the virtual tourists, saying, I think, all things told, this is the most attractive virtual tour thing that's out there. All right, compared to any other solution on the market. Hey, it works the best, it's the cleanest. You can add notes and all kinds of data tags to these things, and you can do some really neat virtual tours, powerful virtual tours from here. Eh, That we're going to jump over into Navisworks and take a look at really what this stuff sort of looks like in CAD. Eh, We'll start with just looking at the actual CAD model like we talked about. Eh, Obviously in CAD this is going to look clean. It's a Revit model it's brought in. But let's start toggling on some point clouds. We'll start with traditional data. This is traditional terrestrial data. Eh, And we can move through here. I know this won't necessarily stream the best for the internet. I'm trying to go slow. What I can tell you is on my screen, this is very fluid and it moves very quickly. But I understand that going through the Zoom, it's not going to be the best. Hey, we can tell some of the things that I'll point out in here, just because when we look at other data, you might notice is different. This data is relatively clean. We don't see a lot of, you see some, but we don't see a lot of random points in here that are just sort of floating in space and aren't really, shouldn't be there. Um, some of the trickier stuff is like this curtain wall type detail here. Does a good job of picking that up. Black objects, it does a good job. A lot of devices struggle with black because it absorbs all the laser light. Um, but overall, very good data quality here. All right. Shut that off and let's jump into, I'm going to skip the BLK to go for now. But let's look at some VLX data. Okay. Again, you can tell, if anything, I think this data is even cleaner. The color capture is even a little better, albeit a little dark. But here's where you can start to see some of the issues pop up with some of the more complex geometry. But this is where I said earlier, right, that Navis is probably fine for most projects, right? We didn't really need to get all the detail on this mullion, right? It's fine. You could certainly reconstruct this curtain wall from this data, and a lot of it is even cleaner looking than the terrestrial unit. One thing I should point out, this data is all um, an immediate export. This has not had any kind of like secondary cleanup done to it. There are tools in all of these programs to do data cleanup and make it look a little better. Hey, last thing I want to look at, or second to last thing, is this Matterport data. They say I just got this in, so I actually haven't had a chance to align it to the CAD model yet, so we got to zoom out a little bit. Then we jump in here. All right, this data is, what I can tell you is this is an order of magnitude better than the Matterport 3 or 2. But you can tell it's still a little off, right? We still see a lot of random points floating. Um, again, good enough for a lot of work. Not good for some other types of work. I mean, but overall, not terrible, right? Pretty good. Um, Lastly, I'll just jump in here and I'm hoping to get some more data from these mobile units, handheld mobile units pretty soon. Um, right now we don't have a lot of this, but we'll look at some BLK to go data. This is one of those handheld units. Now this one does support color capture, right, to a certain extent. Let me jump into some kind of the similar space so that we're looking at the same thing. This can even be a little hard to see. I've been told that this weird kind of striping thing it's done, that's been improved in the newer units. But I can tell you all these units do have this problem that they're sweeping and they can be a little weird. This is, it has its uses perhaps, in that, yeah, I guess I'm not even necessarily sure where this has its use. There's some oddities, like I know these units are popular in mining and some other difficult to access locations. But this took about the same time that, let's say, a Matterport would have, and that Matterport data in my mind is better than this. Um, and it was a fraction of the cost for the device. Hey, yeah, if anything comes up, obviously feel free to reach out, and we're always happy to help out and answer any questions you might have. There's my email for anyone that needs it. I appreciate everyone showing up for today and sticking around.